So welcome back to today's class. And for this particular session, I want us to talk about memory management in Oracle database. Now, as you all know that when we talk about a database instance, this is actually an involvement of two things. We have the memory and we have the background process. We have the memory and the background process. So when it comes to memory and background processes, this equals to a database instance. Now, we all know that when we talk about memory or the Oracle database memory, we are talking about, it's actually subdivided into two sections. We have the SGA plus PGA. So these are two very important memory components as far as the Oracle database is concerned. And of course, the SGA stands for Shared Global Area. PGA stands for Program Global Area. So I know by now that if I give it as an initial SGA and PGA, you all understand. Now, in these memory components, we also have, of course, we have some sections or components that makes up SGA. We have components that makes up PGA. And if I can just shed some lights on that, you'll find that when you talk about the shared global area, which is equals to SGA, we have these components. For example, we have the shared pool, we have the database buffer cache, we have the large pool, we have the streams pool, we have the Java pool, and the rest. So when it comes to managing, or when it comes to managing memory or memory management, we will end up talking about some of these components because you see, we will be immersing ourselves so much on either the SGA or the entire memory. That means a combination of both the two. So when we talk about the memory, yes, Robert? I'm good. So already the session is on. Yes, so you can continue as the rest join us. Yeah, so for this case, we are talking about managing memory or memory management. That is a topic we were supposed to do it by yesterday. And for this case, we are talking about how can we manage memory. So I've actually started by mentioning the two components that makes up a memory, because when we talk about a memory in Oracle database, we are talking about SGA or PGA. Now, we have something called the database instance. Again, that word, sometimes we end up, encountering that. And of course, this refers to a combination of memory and background processes. So in this case, we are talking about the memory, and we need to understand how can we manage this memory. And of course, management of the memory, of course, again, takes you through to a point where you need to understand the components of each subsection of the memory. For example, the SGA, which stands for the Shared Global Area. And of course, we have some of these components: the shared pool, the database buffer cache, the large pool, streams pool, and Java pool. Now, so talking about management, we have two ways of managing. Talking about management or memory management. Remember, it's about the Oracle database memory management. Of course, we have different ways of managing other types of database, especially the memory. And for this case, I want us to know more about memory management as far as Oracle database is concerned. Now, We have two ways of managing. We have two ways of managing the memory. And managing the memory means we need to understand. We need to understand its parameter files. We need to understand its parameter files. Now, one thing we can do here is just to show you the combination. So we have this tool, which is actually show parameter memory. So these are the components that, so if I press enter, you can see that we have a lot of information or a lot of parameters that are involved. This is the memory. But I don't want you to concentrate so much on the upper part. We have the lower part here. And here means that we have to talk about the memory underscore max underscore target, which by default is given as 0. We need to talk about the memory underscore target, which again, the value is 0. So this means that the memory underscore max underscore target is of course in disable mode because it is 0. So it means that it is not in a position to maximize or to consume the size of the memory allocated. So memory max target, memory underscore target. So those are two keywords that we will talk about. Now, again, we need to talk about this parameter, show parameter SGA, show parameter SGA, or at some point, I can talk about show parameter. Okay, let me just have SGA. Now, show parameter SGA. This is one of the component of the memory, which stands for shared global area. And you can see that we have something here called SGA underscore target. So this one is a parameter, SGA underscore target. Now, if you look at its allocation or its the way it's allocated, you can see that the value is not 0, but it is 2192 MB. So it means that out of the space allocated to memory, SGA has already taken care of, has already consumed or has already used 2192, memory, that is the MB. So what happens here is that as far as we want to understand how we can manage the memory, or in Oracle database, we will interact with the SGA underscore target, which of course has come out as a result of us querying this, show parameter SGA. And here we have something called SGA underscore target. So if you want to know the size of the memory as far as SGA is concerned, or the size of the SGA allocated, or the space allocated to SGA, then you have to query this, show parameter SGA, and you can see this parameter called SGA underscore target, and you can see that it has 2192 MB, 2192 MB. So that is the space allocated. Now, probably the question you're trying, or probably the question is, how can I view the PGA? Now, we also have this parameter, show parameter target, show parameter target, show parameter target. So if you press enter, now you can see it's bringing both sides. Now, what you can see here, you can see that we have these two, memory underscore max underscore target. Now, when we talk about the memory underscore max underscore target, this is the maximum memory allocated. Memory underscore target, this is the memory allocated, the space allocated to the memory. Now, you see, if you allocate 20 MB to memory underscore target, then you can still allocate around 40 or 50 memory underscore max underscore target. So you will always end up having the higher value attached to memory underscore max underscore target compared to memory underscore target. But now you can see that both of them, the memory max target and memory target, the value is 0, 0. Now, here we also have the two parameters here. Both of them are actually allocated. A value has been allocated to these two. Now, this is PGA. PGA underscore aggregate underscore target. This is always a parameter attached or connected to the PGA memory. So you can see that 728 MB of the memory space has been allocated to PGA. SGA underscore target is a parameter connected to SGA, and you can see that it is the value attached to that, or the value assigned, is 2192 MB. So for this case, before even we move, I want you to see this mathematics. Memory underscore target equals to SGA underscore target plus PGA underscore aggregate underscore target. Now, this is the maths I want you to have in mind. So for me to get the memory underscore target, this is actually the target memory size that has been allocated to both of them, to both the SG and the PG. So if I want to get the memory underscore target, which of course by this point, by default is not assigned, then I have to add the SG underscore target, which is being displayed here, SG underscore target, which is 2192, plus PGA underscore aggregate underscore target, which is being given here as 728. So if you add both of them, the 728 plus 2192, you get what we call the memory underscore target. And probably what you're wondering why memory underscore target here is 0 is because of how this memory is being managed. So we are going to have a look at the two types of management, or the two types of memory management. Now, for you to capture all of this at a go, all these parameters at a go, then you can just execute this parameter, which is show parameter target, show parameter target. Now, so that is the formula you want to know. Again, we also have this table, $V SGA info. We also have this dynamic performance view table, which is actually called SGA info. If you press enter, you can see that we have these columns. Now let's see what is happening. Let me choose all of them. Select name, bits, resizable, con underscore ID from $V SGA info. Okay, I think there's a resizable, size. Yeah. Now, this is what? This is, I've actually selected everything from that table. Even without, I could even use select star from $V SGA info. Now, what this tells me, you see, it's giving me almost the sizes of the SGA components. So just picture out the way we did discuss the SGA memory, or the SGA components, or the shared global area components. And of course, you can see that we have been based on this, what is being displayed here, you can see some related information. For example, Java pool, large pool, shared pool, streams pool, we have buffer cache. Now, all this makes up the SG. All this makes up the SG. So you can also see, of course, we also have added information here. You see, even if you want to get the free SGA memory available, you can still look at it. But the most important thing is that each one has been allocated a space. A space has been allocated in terms of, I think it's KBs. This is in form of KBs. Now, the resizable here, represented by res, you can see there are those columns or rows that have the resizable no. So if resizable is no, then it means that you cannot adjust. The system allocates automatic the bits. You see, it allocates the bits automatically. Now, those that have the yes, it means that they are adjustable. You can readjust them. So for the no, you cannot adjust them. For the yes, you can adjust. Adjust means you can alter that size. If it is 46.97, you can still even reduce it to 20 something. You see, that is the adjustments I'm talking about. So it's allowed for you to adjust these SGA components. So those are the few things I want to probably talk about as far as memory is concerned. And of course, we have these parameters. There's so many parameters you can use. You can use show parameter target. You can use show parameter memory. So if you talk about memory, show parameter memory, if I repeat it, you can see show parameter memory can give us this. This is only connected to the memory. Of course, that memory is a combination of both SGA and PGA. So you can see memory max target memory underscore target. Here, we do not have any SGA underscore target or memory, or PGA underscore aggregate underscore target. Now, if you want to go to the other side, now this is where you can use what? The target. So the target can give you everything on board. The target can give you everything on board. So you can see we have the memory max target, memory underscore target. We have the PGA underscore aggregate underscore target. We also have the SGA underscore target. So having learned about these parameters, it is now high time for us to understand the management or how can we manage memory. So here you can say that Oracle database memory can be managed through the following methods, through the following ways or methods. So you can have, like, number one, we have something called automatic. So we have the automatic memory management. This is represented by AMM. You will always find us talking about AMM. Number two, we also have the same thing, but this time around we have the automatic shared memory management. Shared memory management. This one is ASMM. So here we will talk about AMM and ASMM. So just to know what it stands for, because that is the shortest route or the shortest way we can talk about them, rather than going a long way and having a full meaning. So automatic memory management, that is AMM. Automatic shared memory management, that is ASMM. Now, for automatic memory management, if I can just talk about it a little bit before we look at the practical part of it, you'll find that the automatic memory management enables specification for total memory provided for both the SGA and PGA. Let me repeat. AMM provides the total memory. So here I can say AMM provides, provides the total memory for both the SGA and PGA. You see, that is AMM. It provided. So if you combine the total memory size for SGA plus PGA, then of course that gives you or takes you to an automatic memory management, which I'm actually talking about it here as AMM. Now, the allocation is set in you see, there's a point I was telling you people that there's no way that SGA will surpass the PGA in terms of, in terms of the memory consumed, in terms of the, its operation, because SGA always ends up having more components than PGA. So we can say that the allocation of space or the allocation is set in a 60-40 ratio. That means 60 for SGA and 40 for PGA. So there's no way that you can end up getting the PGA having more percentage compared to SGA. So even if I talk about the 60-40 ratio, it's not always, because you can end up even having SGA getting 70% and the PGA getting 30%, or SGA getting 90%, and then of course PGA getting 10%. Now, so just to know that for the AMM, it enables specification for total memory provided for both the SGA and PGA. The SGA components will be allocated memory automatically depending on the workload. So as long as you're talking about the AMM, the space allocated or the memory allocated or the memory is going to be allocated to SGA automatically, because you see, based on the two methods, the AMM and ASMM, remember we have S in ASMM. That stands for the shared. And shared means it's actually the SGA we are talking about, because SGA stands for the shared global area. So in this case, it means that when you talk about configuring your database, or when you talk about configuring the memory, not even the database, but configuring the memory as show parameter memory, you'll find that we have these two: memory underscore max underscore target, memory underscore target. Now, let me give you the difference. You see, when you talk about the memory underscore target, this is more dynamic. It is actually the dynamic parameter. It keeps on changing. Memory underscore target is a dynamic parameter, and it keeps on changing. Now, on the other side, you'll find we have the memory max target. Memory max target is the opposite of memory target. So since memory target or memory underscore target is dynamic in nature, then memory underscore max underscore target is static in nature. And you see, when you talk about dynamic parameter, means that it keeps on changing. For static parameter, it ensures that you cannot set the memory target to a value higher than the memory max target. You see? So this is the reason why we are having max. This is the maximum memory target. So there's no way that you can set the the allocated space for memory target that can go beyond or greater than the memory max target. So by default, the system knows what is your max target. And of course, for memory underscore target, this is dynamic, so you can set it based on the given value on the memory underscore max underscore target. So just be careful. Anytime you're given that mandate to adjust the memory components, ensure that the memory underscore target is always lower than the memory max target. Now, so by default, we have two methods or two ways of adjusting. So I have said one method of memory management is AMM or AMM, which stands for automatic memory management. And of course, this one is a combination of SGA plus PGA. This is a combination, and it is automatic, and it is there by default. Now, we also have another one, which is ASMM, probably for Daniel who has just come in. So AMM stands for automatic memory management. And then ASMM stands for automatic shared memory management. So just for the sake of, so automatic memory management. Okay. And then of course, which is connected to SGA and PGA. Then of course, we also have the ASMM, which of course stands for automatic, which is actually the same thing, automatic shared memory management. Okay, memory management. So don't worry about that, but at least you have a clue. So the question is, how can we switch? You see, we need now to learn or to understand this concept. As long as we are talking about management or memory management, we need to understand how can we switch from AMM to ASMM, and how can we reverse it from ASMM to AMM. So there are two questions here: how to switch, or number one, switching from AMM to ASMM, and another one, switching from ASMM to AMM. So you see, it is the opposite of each other. And this is the practical part I want you to know. Now, another point is that, you see, when your memory management, or when your memory is in AMM, it means that the system is managing the memory for you automatically. So it means that you do not have any interaction with the memory. That means you cannot alter the memory unless that memory is in the second method, or in the second part, which is actually ASMM. And again, something here. For AMM, it is actually a combination of both SGA and PGA. For ASMM, this is only tuned to SGA. It is only tuned to SGA. So that is why we have the letter S, which represents shared. So I want us to start from this perspective. I want us to start from switching from AMM to ASMM. That is where I want us to start from. How can we switch the memory from AMM to ASMM? So I'm going to give you a step-by-step guide. So just understand the topic, how to switch from AMM to ASMM. And then, of course, we will reverse it. So here it means that, of course, I'm going to have it, okay. So I'm going to have it. So number one, I'm going to give you like procedure. I mean, the first step, probably as you write it, or so that I do the practically part of it. So first of all, we need to determine the total memory currently allocated to SGA. So here I can say, first of all, number one is to determine, okay, determine the total memory allocated to SGA less unused space. So that is what we need to do. Unused, okay, instead of space, let me just use unused memory. So you see, here we are talking about the memory which is purely allocated to SGA. But as long as you see, you can allocate like 70, but only that is used. So we need to get what is being used by the SGA. What is being used by SGA? And this means that we need to execute a query. We need to execute a query. So let me show you this query. So this is the query. You'll just talk about select, then into bracket, select, I want the sum into bracket value. First of all, if I can just describe this table, a table called describe $SGA. You can see that we have this value. We have this value. Now, if I select star from $SGA, you can see that for the value, we have all this information. The fixed size, we have this. Variable size, we have this. Database buffer, we have this. And then redo buffers, we have this. So what I want to do is I want to get the sum of all this. I want to get the sum of all this. Now, we also have another table, which is actually called SGA underscore. So describe v dollar SGA underscore dynamic underscore free underscore memory. You see? Now, if I come back to this point, and just say select star from and press enter, you can see that the current size 0, the corner ID 0. So this is the current size. We need to talk about the current size, and I'm going to combine this particular table, of course, in line with its one of its column, which is the current size, and then of course with the SGA, So how can I combine these two so that I can get the total memory allocated for SGA less unused what? Less unused memory space. So let's go. So this is the query for number 1. So select into bracket, select, I want to get the sum into bracket value from v dollar SGA, now less, so I'm going to subtract. So the total memory minus the unused. So I'm going to subtract now. So what I'm going to subtract? I'm going to subtract select current underscore size, which is what? It is this one. From v dollar SGA underscore dynamic underscore free underscore memory into bracket, and then I will just say SGA, just to give like an alias. It's more like an alias, if you still remember an alias. So I'm going to give like SGA, then say from dual. If you remember dual is actually a dummy table. Dual is a dummy table that is being defined by one column, or a dummy table. So now if I press enter, now you can see I'm capturing what? I am getting the SGA target. So this means what? This is the used memory. So based on the question, or based on the number 1, that how can I determine the total memory used by SGA less unused space, or less unused memory space? So this is how you do it. So that is number 1. So we have this value. So once you have this value, you can copy this value. Just copy. And then we go to number 2. Remember, the topic still remains. We are trying to switch from AMM to ASMM. Number 2, we need to set the SGA target to the value we have. We need to set the SGA target. We need to set the SGA target to the value we have here. So this one means that I need to come back and say alter system set SGA underscore target equals to, then paste this value. Paste this value. And then of course, because we are trying to make some changes into the system, probably I can even end it there. You see, system altered. So it means that I have successfully managed to assign the SGA target. Now remember, this one, I didn't actually assign here. It was not assigned here. It was only given as a result, just to subtract the total memory minus the unused. And then of course we have this. So we want to tell the system that this is the SGA target size, or this is the SGA memory size. Number 3, step 3. Step 3 is to set SGA components to 0. So set SGA components to 0. Now, when you talk about these components, this includes, for example, the streams pool, the large pool, the Java pool, the database buffer size. You see, we need to do what? We need to set them to 0. So I'm going to start with one of them. So here it means that we will have the same thing here. So we're going to say alter system. Now let me just bring it here. If I try to do okay, let me just say select star from $SGA info. You see, $SGA info. So number one, we have the shared pool. So I'm going to take you, we're going to have some selection there. So I'm going to have this set system, then we have shared underscore pool underscore size. Remember, this one is a what? This one is a configuration now we are trying to perform. So just say equals to 0. Is this an O? Okay. Let me just say, oh, yeah. So if it is 0, just put it 0. Press that. You can see system altered. Now I got an error here because I put an O, not 0. Now another one we can talk about is large pool. So I'm going to put it, so this time round is just to change this. Large pool, 0. I'm going to have streams pool. Streams pool. Okay, let's see what is happening there. Streams pool is supposed to also capture 0. So we have around 5. We have around 5. Alter system set streams underscore pool underscore size. We expect it to also 0. So they are around, first of all, remember we are adjusting the main ones, the shared pool size, the large pool size. We also need to talk about the Java pool size, and of course the database buffer cache size. So I don't know. So let's just wait for that. Okay, so don't know why it's taking time on the alter streams pool size equals to 0. Okay, let me just use a different platform and see. So this is how we are adjusting, or this is how we're trying to switch from, okay, let me open another one as I wait for that. 36. So it will be conf/assistDBA Oracle. Okay, let me share this one. Okay, so okay, so let's pick from there. So I'm going to have alter system set. Now I need to have db cache size equals to 0. Yeah, and then I'm going to have now this is the database buffer cache. I'm going to have the last one, Java underscore pool underscore size. Now let me repeat the same scenario for streams. Okay, so I think we have an issue with streams. But this, remember, streams means it actually takes a lot of avenues. It takes a lot of avenues, especially when it's connected or when you try to alter it. Now, okay, let's know more or less about that. Now, so what happens is, sharing closed. Okay, so let me still share. I don't know. So those are the adjustments of the SGA components. The adjustments of the SGA components, I think we are done. So let me just open up another SQL Plus and I'll share. So con sysdba, Oracle, then we'll increase in size so that we can continue from there. I want to have the 28. Okay. So for this one, since that one has become chronic, then of course we can end up using a new one on that note. So, so on this point, we need to move to the other section or the other, after setting the SGA components to 0 or connecting them to 0, it is now high time for us to perform the last one. And the last one is to complete the switch by disabling the AMM, is to disable the AMM. And how can we disable? How can we disable? Now, you see, for this case, by default, if you have the database with you, by default, the memory management that is active is actually the AMM. So if you want now to fully convert from AMM to ASMM, then you have to do what? To switch, or you have to not switch, but to disable. So you have to say this alter system set memory underscore target equals to 0. And then of course you can say scope equals to, you can have it equals to memory, but I think it will not take that. It will take the SP5. So it will tell you what? Altered, system altered. So it means that I have actually managed to disable the AMM. By assigning memory underscore target equals to 0, it means that the AMM has been disabled. And this means what? This means that I have successfully managed to do what? I have successfully managed to switch the automatic memory management to what? To ASMM. So probably for Brian was just come now, we are talking about how can we manage the memory, especially the Oracle database memory, because yes, we have other databases out there and we have different way of managing their memories. But in this case, we are targeting on the Oracle database memory, and we have two methods of managing this memory. The first one is the automatic memory management, which has an initial AMM. And the second one, we have automatic shared memory management, and that is ASMM. So you need to compare between the two, AMM and ASMM. So what we've done is that we've managed to switch from AMM to what? To ASMM. Now, the next step, I want us to see, how can we switch now the opposite? I want us now the opposite. Switch from ASMM to AMM. Switch from ASMM to AMM. Switch from ASMM to AMM. So just know that based on the given examples, number one, and of course, the first step for you to switch from AMM to ASMM, one was to determine the total memory allocated to SGA less unused space. And then, of course, secondly, you're supposed to ensure that you connect that particular size or this, the amount space you captured, and then assigned it to SGA underscore target. And of course, we end up at changing or setting the SGA components to 0. And then now we are trying to alter or to disable the AMM so that we can have the ASMM fully functional. Now, so this time round is that if I just check show parameter memory, you can end up getting the memory underscore target equals to 0. So this tells you what? This, of course, tells you a lot about the type, which memory management method is active. Is it the AMM or is it the ASMM? So for this case, it is actually the ASMM, which is active. So, and how active it is. You see, when we have assigned the values to the SGA target, for example, show parameter SGA, you can see that we've assigned the value SGA underscore target to what? To 21, to 2192, to 2192. Of course, this one is megabytes. If we convert it to bytes, then it will give us the previous value. Now, so let me take you back to a reversal process now. Switching or how to switch from ASMM to AMM. So that means switching from the automatic shared memory management back to automatic memory management. So how can we do that? How can we do that? So for us to do that, we need to work on this. We need to, first of all, operate on this. And for this part, we have some few steps. Even if you compare the steps, So when we talk about the ASMM, before we convert it, you see ASMM enables specification for total SGA memory only. Remember the other one, the AMM, we said it enables specification for the total memory for both SGA and PGA memory. But for ASMM, because of the word shared, which of course is an initial that stands or that starts when you talk about the SGA, this ASMM is only, it enables specification for the total SGA memory only. And of course, the Oracle database automatically allocates memory sizes dynamically to the SGA components, So of course, following that, we have the parameter SGA underscore target. And of course, you've seen it, be querying about that. And yeah, so what we can do right now is, I want us to work with this plan. And for this part, I want us to determine or to switch. How can we switch? So if you remember the process, of getting the memory target, I say that memory, and I want us to do this mathematics, memory underscore target equals to SGA underscore target plus PGA underscore aggregate underscore target. Now, so having this, let me just press enter. So this means what? Don't worry about the error given down here, but let's concentrate on this equation. So first of all, show parameter memory. Let me go direct. Show parameter memory target. Now you can see that the memory target is 0. Now let me go again. Show memory. This one is SGA target. You can see that. And then let me go again to this. PGA underscore aggregate. Yes. Yes, this one now will allow us to perform this mathematics. So we are talking about the memory target, which now the memory target is at 0. The default is 0. So for us to get this, we need to find out the value attached to SGA target, which is what? 2192 plus PGA. This is the parameter for PGA. It is what? 728. So if we can do such mathematics, if we can do this mathematics, I think we are getting what? We're getting 0, 1. So we can do it. Okay, let me just open my semaqueli here so that we can do such mathematics. Because for, you see, for mine, it's different. So 2192 plus 728, I get 2920. So it means that if you took about 20, let's say 2192 plus 728, we get what? You get 2920. Now, this is what we mean as what? As memory underscore target, as memory underscore target. So as we proceed now, we need to work with that. So first of all, you have to determine the value of memory underscore target. So already we've determined that. And then we need to change. We need to alter that. So I think for the alter we had here. So I am going to replace this. Instead of 0, I'm going to have is 1920 and press enter. So alter system set memory target 2920. Now, if I come here and try to prove the point, now you can see that it is still 0. Why is it still 0? It is still 0 because the scope here is SP file. So for me to see the changes, I need to restart the database. So I will just say show immediate. So I need to shut down the database and start the database so that I can see the changes. So let's wait for some few minutes. So as we wait for it, okay, there it is. Okay, there it is. Now we are done with that. So let me start the database, startup. So you see, when you have the scope equals to SP file, you will be forced to start the database. So let's say specified value of memory target is too small, needs to be at least 2912 M, failure and processing system parameters, 2912. Okay, 2912. Now, what happens to this? You see, already I'm encountering an error. So let's correct this error so that we can see what to do. So let me just share, I think I shared everything. Let me just correct this error so that we can see what is happening. Okay. So let me share the all. Now, so for me to work on this, remember I'm talking about this. So for me to share this, to solve that problem, I will just go back to my home page. I'm going to the Oracle database default path. So mine is at C. I'll go to app. So what I'm looking at, I am actually looking at the P file or the SP file. So DB home, I'll come to database. So I want to talk about the SP file here. So since it's actually editable in it, but let me just open the SP file. Now it will give me all this information. And I think we had, if you look at the memory target, it is 2920. And here we are getting some information here that the memory target is too small, needs to be at least 2912. Needs to be at least 2912. We've given 2920. So let's see what is happening if I adjust this file. So this one is at least 2912. So this one you can adjust it manually. Come here, save it. And then let me repeat it. Let me shut it down again. Okay. So I am shutting it down. So let's wait and see. Okay. Show immediate, Oracle not available. Okay. So let me just cancel. Let me start it again. Okay. So let me just properties 28. Now let me connect it as DBA Oracle. Let's see. So it's going to give us more of an error like connected to an idle instance. Let me start up. So whenever you see such an error like connected to an idle instance, just issue startup. Just issue startup. So let's just wait. So let's wait, we see what is happening. So this is the issue, or this is how startup always takes time. And I know probably for your case, if you do it again, like you assign all the like the value, the SGA plus the PG, it always gives you this kind of an error. So I think the only thing is it requires some bit of like an allowance. And now you can see that it's giving me another error, control file, this one version consistent with file, which is version 11.200. I don't know. Okay. So sometimes it can. Okay, let me see on this other part. You see the file we just this init.cl. Yeah, I think we can adjust from this point, but I don't know whether it's available. You see the Sga Target and DTBS aggregate. Now you can see we had this one, we had this 2184. So DB block size. So we have a lot of configurations files. And I can see that already we've ended in a ditch. just to come out of such such errors takes you a lot. So I think we did actually give a lot of, I mean, the full, at least we should have given some allowance on the, rather than altering the system and setting all the information here. Now, okay, don't worry. Now, so what happens here? I don't know. What happens here? You see, this is more of like the last step. Where was it? Okay, this was more of like the last step. Okay, let me see whether I can correct. So we have the control file, order data, this version, this inconsistent with this version. Now let me start it using, let me start using the PGA. Let me start by PGA. So con sysdba. Now let me start. Okay, this one is already connected. Okay, now so for the last step now is, you see, the first step is now to bring up the memory. Let me say show parameter memory. I want to see whether it may come. Yeah, and the memory target, I think, is still at 0. It's a take effect. I think it's a take effect, and you're supposed to have done it. So now show parameter target. Show parameter target. So show parameter target. So we had the PGA. This is the combination of this and this. And then we had the memory underscore target. Now let me do it again. I think we were getting around, this one is 0, 29, 29, 20. Let me alter system, set memory underscore target equals to, let's give something like 2920, let's say 2900. Scope equals to SP file. So write to SP file requested, but no SP file is in use. No SP file is in use. So in this case, I think I'm experiencing an error with my SP file. But again, we can end up, let me just do the memory. Of course, it will not work because it has to take, you see, specified value of memory target greater than memory max target. So I think for this part, I need to readjust my SP file so that it works. Now, let me see. We have the init ORCL here. Let me capture this path. Let me see. So I will just paste here, and then have init ORCL. Okay, that is the file. Now from this point, I want to copy all this, and then I want to. Okay, let me see. So I need to create SP file. Create SP file from P file. Okay. Now, if I come back to this point, do that. Write to SP file requested, but no SP file is in use. Yeah. So now, of course, this is the last step in converting it. You see, if we make sure that the memory target is given to 2900 or given to an addition of or is assigned to the size, I mean, coming from the combination of SGA and PGA, this is how we end up at converting. So you see, in switching from ASMM to AMM, this does not require us like to have more than 3 steps. It's only 2 steps because already 1 step has been done for you, which is of course setting the SGA components to 0. So it's all about now adjusting the memory underscore target. So if you can make to set the memory underscore target to take the value of the combination of both SGA and PGA, then you end up getting the ASMM. So I think probably in our next class, I think I'm going to adjust my SP file so that we can terminate on that. And of course, we'll start from that point because we need to have all these things clear at our fingertips. Yeah, so I think that marks the end. That marks the end of our session today. And of course, we've managed to talk about memory management, and we've seen the two components, that is the ASMM or automatic shared memory management, and the AMM or automatic memory management.